In this video, let's start working on the tests on differences between means when we have dependent samples, and we see that we have two types of them. Let's understand the distinctions and the similarities between them. So what's the similarity? The idea is this, that we're going to have one sample and two subgroups. And I have a videos in the playlist where there was this question about the salespeople who received the training to increase the sales. So the same salespeople, I'm going to write this as a common thing because they belong to both types, and then we're going to see how we're going to understand the distinctions. So we had salespeople, we have over here salespeople, and they received trainings. So the same salespeople, we compare the data of their sales before the training and after the training. So these are the two subgroups of the same sample, before training and after training. What is dependent here is dependent because we have the same salespeople that we're measuring the results on. That's why it's called pairs. We're matching the same people to two subgroups, and we're doing so in a t-test. We're going to do so in a sign test. The only difference between them is that this one assumes a normal distribution, aka parametric test. So this is considered a parametric test, whereas the sign test assumes the same thing, that it's matched, are matched pairs, but we are assuming a non-normal distribution. So it's a non-normal distribution, aka non-parametric test. Already in the next course of statistics, we go into more non-parametric tests, but this is the first one that they introduce in this course. So non-parametric test. Now, with that said, this is the distinction between them. This is the similarity between them, that we're measuring the same sample in two subgroups. Let's see how this works out. In this video, let's do the matched pairs t-test. In the next one, we're going to do the sign test. So the matched pairs t-test, as it says, it's a t-test on differences. So we're going to have some differences, and it's going to be very similar to what we've done so far. Over here, matched pairs t-test, we go below. We're having a t-test where we take the differences between those results. So it's going to be the average sales before the training. Let's keep this let's keep this example, or in other words, let's do it after training versus before training because it's more intuitive. We want to look after and compare it to before to see if it increased or not. Minus X bar before training, so the average sales in the sample before the training, relative to the sample standard deviation of those differences. That's something that usually is given to us in the data. Sample standard deviation of those differences divided by the square root of the number of pairs that we have. N stays for the number of pairs. So in that case, where I have it in the playlist in the question, it's 10 pairs, but this could be any number. And if it's a small number, which usually is, we're using the sample standard deviation. And if it's a large number, we could use the Z critical value. But for the sake of the example, let's assume we have a small sample of 10 observations, and let's design the test, which we just did. Let's see what the critical value is and what the confidence interval can tell us. Now, to give a conclusion for the test, we need to compare this as always with the t-critical value. Let's do it over here below. What would be the t-critical value? Well, the t-critical value, and by the way, under the hypothesis, let's just write the hypothesis here as well. Under the hypothesis that the sales before training and after training are equal, so the mean sales before training equals to the mean sales after training, and the alternative would be that the mean sales after training are bigger than the mean sales before the training. So it's a one-sided test, at least in our example, meaning that the t-critical value is going to have the significance level of 5%, for instance. 0.05. We don't divide it by 2 because it's only on one tail, on one side. The degrees of freedom are going to be the number of pairs, and in our case 10 minus 1, and we compare the t-value with the t-critical value. Assuming that we reject the hypothesis, then we would claim that we have enough evidence that the sales increased after training. That's the idea. What else matters here? How can we design a confidence interval? Well, remember, whatever difference we find between them, it's based on sample data. It's not exactly the difference between the population data. So if we take the entire population of salespeople in that company, meaning this is an estimate, so we would like to have, for instance, a 95% confidence interval. It's going to give us a range that's going to contain the differences between the population groups with the probability of 95%. And that's based on the differences we have in the sample, x bar 1 minus x bar 2, plus minus the t-critical value that we're going to use. This one over here goes in the confidence interval. So t-critical value at 0.05 and minus 1 multiplied with the standard error. And the standard error, as we said, we take it from the formula because all the pieces that we need for the confidence interval, we have them already. And that standard deviation of these differences between the pairs divided by the square root of n. And that would give us the confidence interval that we need. This would sum up the test with the matched pairs, the t-test. The matched pairs t-test again, the most important thing to understand is, how do we know that they are matched? They have to have something in common. They have to have a dependency. Like in this case, the same salespeople measuring data before training, after training. You could measure, for instance, the same kids hitting one ball with air and one ball with helium, and we want to know which one is going to fly further. Things of that nature. There has to be a similarity, something dependent in that group. Hope this makes sense. In the next video, we're going to go to the sign test.